My name is Muriel Medard. I'm co-founder and CEO of Optimum. I'm a lead from MIT, where I hold the NEC chair for software science and engineering for the entire School of Engineering. And the work that Optimum is based on comes out of more than a dozen years of work of research at MIT. And why do we say that this is a new model for everything that's happening in Web3? Web3 is a network, and if we look back at what has made networks successful is the ability to access the network. So you need to access the network, and then the network needs to behave like it's a single dedicated resource. If you look at the power network, we know how to access it. I plug in. If you look at Web 1 or Web 3, I know how to access it. I just plug in, but it's just a different kind of plug. So in the power network, basically what's happening is I have a large distributed messy network. We just heard about energy from the previous speaker. But as far as I'm concerned, the whole world looks to me like it's just one battery. Like the world is my battery. And behind it, there's tech that's grabbing all of the different resources from different sources, whether it be a solar panel or a power plant, and it's giving it to me. On the other side here, what you have is, in TCP/IP, it looks like everything in Web 2 is basically like a dedicated link. I have this abstraction, and then I have the tech behind it to make that emulation of a dedicated link a reality. Okay, so what is the plug? What is the abstraction in Web 3? And what is the tech that's going to make that abstraction a reality? Well, what we want is not just to connect, but what we want is to be able to pretend that all of Web3 is just a dedicated computer, just my own dedicated computer, even though the system is decentralized and nodes are coming in and out in a permissionless way. How do I manage to create this plug? So what we have is this FlexSync, this socket, basically so that I can access the block as though it were my own computer. I can read it, I can write it. And then we have the tech, which is the FlexNodes, to make that reality of the tech to enable this access. So, little bit of geeking out, very short geeking out. What does it even mean to pretend that you're a computer? Well, we've actually known this for a while, but it sort of was a little bit out of reach. It was something that people had determined existed as, the actual absolutely necessary conditions, but they were just really hard to get unless you really did have your own dedicated computer. And basically, atomicity, it looks to you like it's just your computer, like your own RAM. Things, the time always goes in one direction. You always have that all of the reads and writes and, no blocks don't go out of order. And you have durability. Your data doesn't get lost, right? It's your computer, you turn it on, the data that you left there is still there. So what we want is to have this atomicity, consistent durability, and to have it in a way where the data just looks to me like it's residing on my computer, even though it's actually residing in this messy ecosystem that is Web3. So we're not creating a new layer. We're not creating a new abstraction other than the abstraction of having this data socket, which is the socket for Web3. This is what's going to make everything easy, in effect. So whether you're at the application, the execution, the settlement, consensus, network layer, you just go into the Optimum data socket. Okay, so what does it mean to work on a computer? You have two things in a computer. You have the compute, hence the name computer, and you have the management of getting data in and out. The two are separate. The two are not on the same processors in your computer, right? So you have your computer has a CPU, it's doing the computing, and it has memory. They're not the same thing. So everything else that people are building, say in applications in Web3, is basically what's going on in the CPU. Everything that's happening in the memory, the reads and writes, that's what we're going to handle so that people don't have to worry about it. So we can read, we can write, we can check whether reads are possible. So, you know, this is such a fundamental question, right? How do I take a decentralized system, not just distributed with coordination, but truly permissionless, truly decentralized? How do I take such a system and make it look like a single computer? People have been working on this literally for decades. The problem is the very few solutions that were out there were so slow. It was as though I told you, hey, look, I gave you a TCP/IP socket. It works great, except it's only 10 bits per second. Nobody's going to want that. So what we have done and what we've been able to do is bring technology which allows not just the socket to work, so really everything to look like your computer, but for Web3 to look like a powerful, fast, cheap computer. And the way we do that is by changing how we manage data. Rather than looking at data as just, you know, pieces of different data chunks that I'm trying to manage and having to keep state, we're creating mixtures, we're creating equations. So everything that we do now reduces to distributing and managing equations. And just to give you an idea of how powerful this is, I'm going to show you a quick video. Okay. So in order to really take this system here and go from having pieces to having equations, I'm going to show you a system where nodes come in and out. So I'm really permissionless, right? I'm not keeping track of who has what. I'm going to have this sort of FlexNode approach, and I'm still having all of these read-writes that are possible. Okay, so I have my data. It's distributed among different nodes, and nodes are not even keeping full nodes. They're just keeping whatever they can keep, and they just have whatever bandwidth they are available to is available to them at that particular time. So what I'm going to have is I'm going to have nodes that come on, and new nodes come in, and there's no node that actually has a full node. Okay, so the question is, can I actually keep this system to still behave like it's my computer? Like, you know, I have these things coming in and out. Can I still pretend that everything is like my own computer? Nodes coming in, nodes coming out. When nodes come in, they just find whatever information, whatever equations are just lying around for them. And here's iterations of these nodes coming in and out, you know, however they wish, randomly. On the left is the current infra. What you can see is the following. On the x-axis, I have bandwidth, right? We want bandwidth to be as small as possible. So I want to be as close to 0 as I can on the horizontal plane. On the y-axis, I have storage / memory per node. So I want to also be as close to 0 as I can. The only dimension I want to be large in is reliability. And a reliability of 1 means my computer is still alive. Okay, I have that durability. So as soon as I go below 1, I have a failure. So you can see with the current infra, basically it dies at around 27 rounds of nodes coming in and out. The only way I could keep this alive is actually to keep increasing, to keep scaling up beyond just the measures there that you see on these. So it's on a loop, so you can see it come in and out. The beyond that plane that we have there in terms of storage and memory. With the equation aspects that we're doing, we can actually stay alive literally for thousands of years. And so what we're doing is we're relying on a completely different way of managing the data, which is managing, I'm not servicing up specific chunks, I'm servicing up equations that are making my system reliable. And this is basically just an illustration, just a picture of how much better it does. We can now be truly scalable in a completely decentralized way while maintaining those primitives, those read and writes that look to you as though you're just on your own computer. So what are we doing? We're turning Web3, in effect, into a decentralized machine. And the technique we use, this equation that sort of using equations instead of the data, is called network coding. It's allowing us to, again, completely free up how we manage the data. And we have two aspects. One is ODS, the Optimum Data Socket. This is like the plug that's allowing you to get into, for instance, the electric grid. And the other one is the FlexNodes. The FlexNodes are what's allowing all of the different node operators in Web3 to provision Web3 service as its own dedicated computer. So we're going to emulate our own dedicated computer. So this is, in effect, the abstraction that's going to power Web3. The idea for doing this, as I said, goes back to over 12 years of research, and it took us that long. It literally took us that long to get this to work. And when we saw that this was working, we also saw that not only was it working like gangbusters. To give you an idea, the benefits that you get in terms of cost, it's about 25x. The benefits that you get in terms of speed is about 10x, which is why I'm standing here with you today. We're very, somehow that slide didn't go through. But let me tell you what's on that slide. We're very, very fortunate to have just completed a seed round with 1KX as the lead. And we have a set of just wonderful funders and also very engaged and very supportive angels. I want to give a shout out to my co-founders, Kent Lin, and also Kishore Kanwar, who's he and I have been working on this in Skunkworks literally for a dozen years. So it's really a combination of a lot of faith, a lot of coffee, and a lot of math, a lot of coding. Here we are, so stay tuned. We're just coming out of stealth, so if you look us up, you won't find much, but coming soon, and I hope to have discussions with you afterwards and see if there's any interest partnering. So particularly if you're a node operator, come talk to us. We'd love to hear about you. Okay, and with that, I have 19 seconds to go. Thank you very much.